Hello everyone, this is Sumit K. Welcome to my channel TheCloudBaba. In this video, I will be talking about AWS managed streaming for Kafka or Amazon MSK. This video is going to be the first video of this series. I will probably creating the playlist on Amazon MSK where we will cover from basic to medium to advanced use case. So this video is focusing on the basic of Amazon MSK, where we will cover the creation of the Amazon MSK cluster and how we can use and send the data, consume the data or produce the data in a very simple demo. So before I talk about Amazon MSK, let's first understand what is Apache Kafka. Let me just open my slide. So AWS managed streaming for Apache Kafka, which means Amazon MSK. Here, the key point is streaming. So remember this point. This Kafka is Amazon MSK is widely used for streaming the data, right? On the streaming data. So let's first understand what is Apache Kafka in general, and then we will deep dive into the Amazon MSK. So Apache Kafka is a distributed streaming platform used for building real-time data pipelines and streaming application. It is designed to handle a high throughput, low latency data streaming, and these are the functionalities or components which are producers, topics, brokers, consumer, and you have zookeeper. So producers are nothing. These are the application that publish messages or data to the Kafka topics. So producer is basically the source of the data who are sending the data, to the Kafka cluster. Now topic, these are like a channel to which the producers send their messages or data, and each topic is split into a partition, right? So I'll talk about the partition and parallelism in some time later. Now, what is brokers? These are the Kafka servers that stores the data. Now, Kafka is distributed, meaning multiple brokers works together to form a Kafka cluster. You can think about Hadoop cluster or any other cluster where in the, or maybe you can also think about Kubernetes cluster where you have a master and slave concept. So same concept is here also in terms of the brokers. So brokers are nothing. These are the nodes, right, which represent your entire cluster, and they work like a slave. Once the work is done, they will report back to the master or the cluster and show the outputs or generate the outputs of this, right? Now, what is consumer? Consumer are basically the application that subscribe to those topics to consume those data, right? So consumer can be grouped together to share the load, right? So now you have to understand, right? These topics like producer, topics, and consumer are the key point here. To you can note down this producers, topic, and consumers. Brokers and zookeeper we will discuss in more details in our upcoming videos. So last is zookeepers. Zookeepers is used by Kafka to manage and coordinate the Kafka brokers. So if you know about the zookeepers, you will understand that the zookeeper is widely used by the organization, especially for coordinating the messages or data with your cluster. But the modern Kafka implementations are moving towards using a Kafka native consensus protocol. So it's not like you should always use the zookeepers. There are many others, the replacement of the zookeepers or natives Kafka native tools that you can also use. Okay, so here this is the Kafka data flow. This is a basic overview. Now Kafka use a pub/sub, which means publish and subscribe model, where producer publish a message to the topic and consumer subscribe to those topic to receive the message. So here this is your topic. This is what I was talking about. The topic can be partition and parallelism. So let me explain this flow in terms of real world analogy. So let's think about Apache Kafka. Let's say, okay, in terms of real world scenario like a radio station, right? So if everyone is using the radios, everyone listening the music on the radios, so we know we actually when we use some frequency in our radio station, we started consuming those data, right? So imagine that the radio station represent a Kafka, which is, you can think about a platform designed to handle and process streaming data. So in this analogy, producers are the various radio channels such as 92.5 FM or Radio Mirchis, right? These are the famous radio channels, right? Now each channel is broadcasting different types of content. Now what are those contents? Like music, news, or talk shows, continuously, right? It's happening continuously. So this content represent your streaming data, such as message or events that producers are sending to the Kafka. Now, each topic in a Kafka can be thought of as a specific frequency of the radio channel, like 92.7 FM, Radio Mirchi, like that. So just as the radio station send its signals to this specific frequency, right? So producer are nothing, these are the radio channels, and topics are nothing, these are the frequency, right? Now the consumer here in the Kafka, we can think about, are like the listeners who tune into a specific radio channels, and these listeners are subscribed to certain frequencies, meaning they are interested in this particular topic within the Kafka. So this is how you can relate this data flow of Kafka into with the basic radio channel frequency, right? How you can use radio in your day-to-day activity, in your day-to-day life, right? So this is how the Kafka data flow. Okay, so now we need to understand difference between the streaming data and the batch data. So you must be aware of, right? There is a batch type of data, there is a streaming type of data, right? Which a lot of companies are used to process those data to get the business insight out of it. So when it comes to the streaming data is a data that is continuously generated in a real time and processed as it arrives. So this approach is ideal for time sensitive application where the value of the data diminish if not processed immediately, right? Example, I can say that a live feed of a temperature, let's say reading from an IoT sensor across a factory floor, and each sensor sends the data every seconds, which immediately process to detect any anomalies, and which ensure that the factory operates within the safe condition. So this is one of the example of the streaming data. Again, the um, radio station example that we have discussed in the live slide, you can take it as in streaming data and process it, right? But Amazon MSK is particularly used for streaming data, right? Not for the batch data. Because now what is batch data basically? Batch data refers to the data that is collected over a period of time and then processed all at once. And this approach is typically used when real-time processing is not required, which allow you to process more complex analysis on the larger data set. So you can think about an example like daily sales data from an e-commerce website. All these sales transactions are collected through the day and processed together at the midnight to generate daily reports, right? And then you can consume it in some data analytics tool, right? So this is the basic difference where between the streaming data and the batch data. And to process both the data, there are different tools, different process that we need to follow. Okay. Now, coming back to AWS managed streaming for Kafka. So as we discussed about whatever we have discussed in the Apache Kafka, which is an open source, this is a managed service. So again, um, different cloud providers use the open source technology, open source code, and then they create a service, the managed service, and offer to their customer. So you no need to worry about the underlying infrastructure or the management overhead, no operational overhead, patching, and all these complex work. You are free of it. So you just focus on your business activities, right? Um, so we will talk about so Amazon MSK is a fully managed service that makes it easy to build and run application that use Apache Kafka to process the streaming data. So behind the scene, this is a Apache Kafka open source code, right? And AWS MSK enables you to build and run application that use Apache Kafka to process the streaming data. So the key point is here streaming data. Now, some of you might be confused. There is an SQS service in the AWS. So why we are using AWS Amazon Managed Streaming for Kafka? But again, SQS is not widely used for processing the streaming data. It's widely used for the event-driven architecture. I mean, again, the use case could be different. If you have a less amount of data, maybe you can use SQS. But for streaming data, especially the larger streaming data where the data frequency is very high, we should use Amazon MSK. Right? Again, there is a many difference. Maybe in the upcoming video session, I will be talking about. All right, so we have covered so much of theoretical part. Now let's jump on to the demo. So if I am already logging to my AWS console, and if you see here, I am already into the Amazon MSK, and there is a cluster already running with the name of demo cluster 1 with this particular version. Okay, the first thing that you need to do as per this diagram, you need to spin up an Apache MSK cluster. So here you can just simply create a cluster. There are two ways: quick create and custom create. You can go with quick create, and you can set your version, whatever your version you want, and the metadata is go with the zookeeper, and the broker size. You can reduce the size, the storage, and all these all cluster settings. So this particular cluster setting is not, you cannot customize it in the quick create. So in order to customize it, you should choose custom create. But I am fine with the default one. So what you need to do before you click on the create cluster, you need to note down this VPC ID, subnets ID, and security groups because it will be used later. So simply create a cluster. Not going to create it because the cluster is already running, and it's gonna take 15 to 20 minutes to make it active. So here, if you just click on this demo cluster, you will see the cluster details, right? The version, ARN number, and here you will see some of the cluster configuration, network settings, all these informations, right? And these are the endpoints. Basically, these are the nodes which is not managed by you; it's managed by the AWS itself. So you don't need to worry about that. And here, if you click on the view client information, you'll get the same detail. So private endpoint, you need to copy this endpoint and put it in your notepad. Okay. Now my MSK cluster is running. Now we have to configure it. To configure it, we need to spin up a client machine. That client machine will be talking to this MSK cluster using some certain roles and permissions. So I already have this is MSK tutorial client machine is already running with with some role, with some custom role. If you look at the MSK client role, it's already open in the new tab. If you see, there is a one policy here. One second, let me show you. Let me show you the role. So this is the role. This is the permission. And if you look at this permission, it's pretty easy. I'm going to give some permission of this client machine to connect with the Kafka and describe the cluster, alter the cluster. It can also create the topic, write the data and read the data. And it can also alter the groups and describe the groups. So the only thing that you need to change is the reason name here, the account ID, where you are creating your cluster, and where is your client machine, and also the sorry this should be the account ID of where your cluster is there, right? And your cluster name, my cluster name is demo cluster 1. Okay, and simply attach this role to this particular instance. Okay, now we need to connect this machine, right? Okay, so here we need to create okay, one thing that I forgot to tell you is that security group, we need to go here because if you see here, MSK cluster has its own security group, right? It has its own security group, and this has his, and the client machine has its own security group. So in this particular MSK cluster security group, in the inbound rule of the security group, we need to allow this client machine to interact with the Apache cluster on certain ports, right? So we need to create an inbound rule. So I already have noted down the security group of this MSK cluster. This is a security group. If you don't remember, you can always go to your cluster here, and in the properties, you will get the security group name here, right? And if you go here, just simply find this security group, click on here, click on the inbound rules, and I think I already added this. Okay, so now search for your EC2 client security group. This is a security group 70F, and you need to allow add an inbound rules saying that you want to allow all the traffic from this particular security group of your client machine, right? So when you save the rule, the client machine will have all the connectivity towards your MSK cluster on all the ports. right? In production environment, you want to use some customized port, but here for the demo, I use all traffic. Okay, now I'm into my client machine, and now um, I have to run some commands over here. So the first command that you will do, just a second. Okay, so here the first command that you need, I think I have already noted down. Here are the commands. We just copy paste his sudo msg. You need to install Java. Apache client needs Java. It's already installed. So now you go back and simply, download this Apache Kafka. So we are actually downloading the Apache Kafka onto our client machine. Okay, it's done. If you see here, we have this tar file. Have to unzip this, and this is the command. Basically, we have to run this command in the libs directory. So you go to cd kafka libs library, and you run this command here. Basically, we ran this command to download the Amazon MSK IAM jar file. The Amazon MSK IAM jar makes it possible for the client machine to access the cluster, right? If you look at the command, that's why it is downloading the IAM jar file. Now go back to cd bin. Here we need to run some command. So, okay, before we run this command, we have to set some client properties. We need to create some file here, and the file name would be client properties. So I'm gonna write this client, and this is the content you need to put here. Oh, 1 second, something wrong. Something wrong here. So I need to copy the content here and just save it. Okay. Now we need to run a command called bootstrapping. So we need to bootstrap. Um, this particular command will be used uh, to create the topic, right? So 1 second. Yeah. So what you're gonna do, you will replace this particular endpoint with the endpoint that you have noted down from the cluster info. So here, if you click on the view client information, these are the private endpoint. So I have already noted down these are my private endpoint, this two one. So you can pick any one and replace it here. And the command config is getting from the client property that we have just created. The replicant factor is 2, partition is still 1, and the topic is we are going to create with the MSK tutorial topic. So just copy this command, and you make sure you are into the bin folder, bin directory, okay, and simply run this command, execute this command over here. Okay, what happened? Authorization is failed. Okay, so actually what happened that I was creating a same topic name again and again, so that's why it is conflicting with the topics. So what I can do, I'm going to create a new topic with the name MSK tutorial 1234, and just simply click on enter. And here we'll see that your topic has been created, your bootstrapping part has been done. Now the second step is we need to produce and consume the data. So to produce the data, what we need to do, we need to run this command, this first command. to produce it, and the second command is used to consume it. So that just change the topic. The topic was 1 2 3 4, and again the bootstrapping servers. This server, I think I already changed it, but let me just change it again. Let's make it second one. So simply just copy this command, come here and paste it. Right, so here this is the producer, and I'm going to tell Sumit K. I mean, I'm here entering some messages or data, right? So the Cloud Baba. Let's open a duplicate of this console because I want to run this second command as a consumer. So here also you need to change the topic name. Come back here. Let's go to Kafka bin, paste this here, and you will see the same messages will be appeared here, right? Yeah, see that? So if I type anything here, let's say Apache Kafka demo. So you will see that you will be seeing this streaming messages here. So this is like a producer is continuously sending a message here, and the consumer is continue to consume those messages here. Right now, this client machine is the only machine who is not just producing the data but also consuming the data. This is just for the basic demo, but think about the real world where let me just show you. This is the one. I will be covering this demo here. Let's say you have a this client machine is going to be the producer. It's continue to produce the data here, and this is a custom connector. I will be talking about the connector in my next video. It's continue to pull the data from the MSK cluster and is sending it to the S3 data, where whatever data that you will or message you will publish here, it will be written into your S3 bucket. So those use cases we will be covering here. We'll be covering in the next videos. So you will be continue to I mean, as a producer you will be continue to doing any messages here, right? Anything here, it will be continue to stream into your consumer side, right? So consumer is going to consume those data, streaming data live, and process. You can also process it. Maybe you can send it to your map reduce, or any maybe you can send it to your lambda function. So lambda function will be continue to or maybe your lambda function will be triggered based on the events or the producer is sending the message. So those type of use case you can bring. Okay, so the last steps we need to cover is the metrics part. So this is how your producer and consumer work, and the topics works. The replication and the brokers are how the replications and broker play the role here. So we will see deeper into it.